wanted to look at some of these free response questions, the ones that actually give you a virtual answer key that you can go back and see how did I do all these problems. So this is the first one with position, velocity, and acceleration. First question said, what was the position at a specific time? So we have a position function, and we want to know at a specific time. So all we need to do is plug in that time. So f of 0. Well, when I plug in, I'll have 0 squared minus 3 times 0. That whole thing cubed minus 1. All this goes away. I'm left with just negative 1. We look for units. They wanted yards. So I'm at negative 1 yards at that point. In the next problem, number 2, velocity function. The velocity function is just the derivative of the position function. So I need to take the derivative. It is chain rule 3 times t squared minus 3t to the second times derivative of the inside, which is going to be 2t minus 3. If you need it like that, great. If you want to bring this 3 and expand it into there, it would be t squared minus 3t squared times 6t minus 9. Number 3, at what moments was I not moving? So velocity equals 0. Well, again, I have a velocity function. I just need to set it equal to 0. So 0 equals v of t, which is the same as t squared minus 3t, quantity squared, times 6t, minus 9. Again, you can use either one, it'll work just fine. I have two factors equal to 0, so I'm going to set all of them equal to 0. 0 equals t squared minus 3t squared, and 0 equals 6t minus 9. I'll do this one first, it's easier. 9 equals 6t. Divide, now I'll get t equals 3 over 2. Over here, I can take the square root of both sides. 0 equals t squared minus 3t. I can then factor out a t. T times t minus 3. That means each one of those is equal to 0. 0 equals t, and 0 equals t minus 3, which means t equals 3. So I have 3 different times. 3 halves, 3, and 0. And that's important when I do part B here. It asks, when was the position when I was not moving? So I have to look at those 3 times. 0, 3 halves, and 3. The time when I was not moving, that came from part C. But we need to use the position function again. We want to know the position at that time. Well, I already know we did f of 0 number 1. That was negative 1. F of 3 I plug in, I'll also get negative 1. These are all yards. And then for 3 halves, same thing. When I plug in, I should get negative 12.4 yards. That's just plugging and chugging. Everywhere you see a T, plug in what you need to know. Part E. At what time did you cross from negative to positive? Well, when you go from negative to positive, you're going to hit 0. So when is the position function? Because you're on a position. When is that equal to 0? So I'm just going to plug it in. 0 equals t squared minus 3t cubed minus 1. Bring the 1 over. 1 equals t squared minus 3t, the whole thing cubed. To get rid of the cube, I need to take the cubed root of both sides. Well, the cubed root of 1 is just 1. The cubed root of this over here leaves just what's on the inside. When I have a quadratic like I do now, I need to bring everything over on the same side. My goal would be to factor if I can, but I can't. So I need to use quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget to sing it if you need to. So t equals negative b is a positive 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1 all over 2 times 1. And you get 3 plus or minus the square root of 13 all over 2. Something you should look for. It says for only t is greater than 0. So I should look at both of these answers. Naturally, the minus, 3 minus square root of 13 will be less than 0, so that won't be good. So really, the only time for your answer is 3 plus square root of 13 over 2. But if you can get to this right here, that'd be great shape for the moment. Then the last one, what is the acceleration at time equals 1? Acceleration is the derivative of velocity. So that's all we're going to do here is find the derivative of our velocity function. As a reminder, velocity function was 3 times t squared minus 3t squared times 2t minus 3. Or if you expanded, or brought the 3 in, t squared minus 3t quantity squared times 6t minus 9. Either way works fine. So I'm going to say, what is this derivative? To do chain rule here, the first times derivative of the second. So t t squared minus 3t squared, derivative of the second is just 6, plus the second, 6t minus 9, times derivative of the first, which is 2 times t squared minus 3t. That'll be in the first power, and then times here on the inside, 2t minus 3. Now, usually I would have to try to expand, contract, try to simplify this. But all we want is at a specific point. So from there, all I need to do is just plug in. I don't need to worry about simplifying it. I might mess it up. Just plug it in right now. So 1 minus 3, 2 here, squared, plus, this will become 6 minus 9. This is still 2. This will become 1 minus 3, and this will become 2 minus 3. Just try to simplify it. Negative 2 here, squared, is 4, times 6 here, plus, this becomes negative 3, 2, negative 2, and negative 1. So I should have 24 plus, and this should all multiply. 3 times 2 is 6, times 2 is 12. And we have a negative, positive, now negative again. 24 plus negative 12, so we're going to have 12, and again if we use units, in this case yards per hour, as my final answer. So there you have it. And again, like I said, once you get to the end, you're going to be able to do something like this with no problem by the time the AP test comes around.